Welcome, ladies and gentlemen. So what I'd like to do is show you how to write the equation of a parabola when the vertex is at 0, 0, or at the origin, given either the focus or the directrix. So the main important thing when we want to write an equation, we need to understand what information do we need. So I wrote two forms of our conic section. Here's going to be when we have a vertical parabola, either opening up or down. And here's when we're going to have a horizontal parabola, either opening up to the right or to the left. And if you look at those two equations, the information that we need, we know that x and y represent the infinite set of points that make up the parabola. But h and k represents the vertex, which fortunately in this problem we know is 0, 0. So we already know the values for h and k. The only other value we don't know is p. But we know what p means. P represents the distance from the vertex to the focus, whereas the opposite of p represents the distance from the vertex to the directrix. So we basically, for these problems, need to figure out the value of p, but not only figure out the value of p, determine if our parabola opens up or down, or opens up left or right. So the easiest way to be able to do that is plot the information you're given. And I tell my students whenever we're doing writing the equation in conic sections, to plot the information you're given. So first thing is we know we have a vertex at 0, 0. So I'm going to plot the information, and I'm going to label it v. The next thing is we have a point -2, 0, and that's going to be the focus. Now what's important about the focus is, remember, that's going to be the point that the parabola opens up towards. So there's, we have four options. The parabola opens up, down, left, right. Well, if the focus is to the right of the vertex, then we know that the parabola has to open up to the right. That's very helpful because now what that tells us is this is going to be the equation that we are going to use. So I'll simply just recreate that equation. And then all we have to do is plug in the information that we are given. Well, we know that the vertex is at 0, 0. So I'm going to plug in 0 in for x and 0 in for k. The only other piece of information we don't know is what p is. But remember, p is that distance from the vertex to the focus. Since that distance is in the negative direction, p is equal to a -2. So it's important that direction matters for our focus. Yes, it's going to a value of 2, but it's going to the -2. So I'll just plug in this information. Y minus 0 squared equals 4 times -2 times x minus 0. OK, now I can just go ahead and simplify. That gives me y squared equals -8 times x. Now, that's in the conic section form. You might see your answer, though, or your teacher might want it in standard form. So when that's the case, what we basically want to do is solve for our linear variable, which in this case is x. So to do that, I'm just going to divide by a -8 on both sides. And what I obtain is x equals -1/8 y squared. All right. In the next example, again, before I even have to do any thinking, let's just plot the information. A focus is a point, and I know the vertex is at 0, 0. 0.01, so that's going to be right there. So my focus is really close to my vertex. Therefore, I already know just on this information, very little thinking I need to do, the parabola opens up. That's very important, though, because now I know rather than using this equation, I need to use this equation. To kind of skip a step, I'm not going to rewrite the information. I'm just going to start plugging in what we know. We know the vertex is at 0, 0. So again, h and k are 0, 0. However, now the distance from the vertex to the focus, because here's at 0, 0, and now this one's 0, 1/3. So that means I traveled 1/3 up. Since that's positive, p is equal to 1/3. So now I write my equation, x minus 0 squared equals 4 times 1/3 times y minus 0. OK, now we just go ahead and simplify. So this gives us x squared equals 4/3 y. So in conic section form, that's perfectly good. If we want to rewrite this in a standard form, I need to isolate the y, solve for y basically. So what I'll do is I'll multiply by the reciprocal on both sides. And then what I obtain is y equals 3/4 x squared. OK, so you could have it in this equation or in that equation, kind of whatever works. All right, now for the directrix. Remember, the key with these is the exact same process that we just did. However, the distance from the vertex to the focus is p. The distance from the vertex to the directrix is opposite of p. Really, really important. But again, the process, we do the same. Plot the information. We know the vertex is here. Directrix, x equals -4. Since here's the x-axis and here's the y-axis, if x equals -4, I go over 4, 1, 2, 3, 4, and that means x always equals -4. So therefore, there's a nice little vertical line. Now, I didn't add it in here, but remember that parabolas have an axis of symmetry. Okay? And remember that axis of symmetry is perpendicular to that directrix. Do you see how I have this axis of symmetry and then I have a line that's perpendicular to it, right? So what that means is if I have a vertical directrix, that means I have a horizontal axis of symmetry. If I have a horizontal axis of symmetry, that means my parabola opens up left or right. So automatically, again, I know I'm going to be using this equation because the y is squared. That's the equation of a parabola that opens up left or right. So kind of like what I did in my first problem, I'm going to write this in. And a lot of times, I'll forget and I'll use the x squared equation. So it is helpful. I kind of skipped it. I kind of just didn't do it over there because once you kind of get used to it, you don't have to. But a lot of students will make that kind of basic mistake. So we know the vertex is at 0, 0. So again, that's going to be h and k. But now we need to figure out what is p. Well, remember the distance from the vertex to the focus is p. Well, p was -2. Well, now the distance from the vertex to the directrix is -p. So we'd say -p is equal to, how far is it from the vertex to directrix? 1, 2, 3, 4. So -p is equal to -4. So when I solve for p equals +4. Now I'll just plug in the rest of the information. Y minus 0 squared equals 4 times 4 times x minus 0. Okay, so therefore I get y squared equals 16x. Again, we can do the same thing like we did over here. Here's conic section form, but if you want to write it in standard form, then we could write it as 1/16 y squared equals x, or you could write y squared over 16 equals x. There's multiple forms. I usually like to have my students write in conic section form as well as standard form. Like this, just so they can kind of see the differences there. All right, lastly, we have a vertex, or directrix here. This directrix, though, is y equals 3. So if, again, here's my x-axis, here's my y-axis. If y equals 3, that's 1, 2, 3. But y always equals 3. So it's a horizontal line. And we just use dot the directrix because it's not actually part of our parabola, as a point x and y. OK, again, my vertex is at 0, 0. So opposite of p, which is the distance from my vertex to my directrix, opposite of p is 1, 2, 3. So that means p equals -3. All right? So again, we use the same equation, but I noticed that if I didn't talk about, well, if I notice I have a horizontal directrix, that means I have a vertical axis symmetry. If I have a vertical axis symmetry, that means the parabola opens up or down. So therefore, I'm going to use this equation, the x minus h squared equals 4p times y minus k. I'm not going to use red because it takes too long. P in this case is going to be -3. And then that's times y minus 0. So therefore, x squared equals -12y, or you could say y equals -1/12 x squared. So there you go, ladies and gentlemen. That is how you write the equation of a parabola given the focus and the directrix with a vertex at the origin. Thanks.